Now we're going to apply what we know about solving what we know about radicals and use them to solve radical equations. So equations that have radicals buried within them. So what you're going to do is the first step you're going to do is you're going to isolate the radical on one side of the equation. If there is more than one radical in your equation, pick one to isolate. The one I recommend that you pick is the one that is the most complex. In other words, the one that has the most stuff under the radical. Okay, that's the one you're going to want to get rid of first. So get that one by itself on one side of the equation, get absolutely everything else on the other side of the equation. Then what you're going to do is you're going to square both sides. That's going to eliminate the radical. Now then, if you still have a radical remaining after you've done this, in other words, you started an equation with two radicals, you can only eliminate them one at a time. So once you get rid of the first one, you're going to have to go ahead, isolate the remaining radical, and then square both sides again. Once you have all the radicals gone, then you can go ahead and solve your equation. Now the last step is absolutely mandatory. You must check your answer in your original equation, because even though you do everything absolutely correctly, there is still a possibility that the answer you come up with will not work in the original radical equation. So always check your work to make sure that what you came up with is actually a solution to your radical equation. So let's take a look at an example here. So we have 6 is equal to negative 2 plus the square root of 4 minus 3u. So the first thing I want to do is I want to isolate my radical. I'm going to do that by adding 2 to both sides. So I have 8 is equal to the square root of 4 minus 3u. Okay. Now that I've got my radical isolated on one side, I'm going to square both sides. Okay. What that's going to do on the left side is I'm going to have 8 squared. That's going to be 64. And then on the right-hand side, the square and the square root undo each other, and I'm left with what's underneath, 4 minus 3u. Now I can go ahead and I can solve for u. Subtract 4 from both sides, and I have 60 is equal to negative 3u. Divide both sides by negative 3. And I have negative 20 is equal to u. Now, before I can say that that is my answer, I have to check it by putting that back into my original equation. So I have 6 is equal to negative 2 plus the square root of 4 minus 3 times negative 20. Okay. So 6 is equal to negative 2 plus... Okay, well, 4, and then negative 3 times negative 20 is plus 60. So 6 is equal to negative 2 plus the square root of 64. Okay, well, I know the square root of 64 is 8. And when I take 8 minus 2, I get 6 equals 6. That checks out. And so negative 20 is indeed the solution to my radical equation.